Hi everyone, it's Joe Davis again from Adult Education Center on Main Street in Winnipeg, and I'm carrying on with my multiplication topic right now in the basic arithmetic. And I wanted to just take a pause from before I go to my next topic, which is division. I want to take one video to explain some very important times table facts to you. It's good if you can learn your times tables up to 9 times 9, but I know for some people that's just a backbreaker to them, and they just can't seem to remember them. But I do want to say that there are a couple, actually there are 4 sets of numbers that I would like you to count by. And that's like learning special times tables, okay? And those special numbers, I mentioned them in previous videos, are 2, 3, 5, and 10. And so what I've done in my class is I've taken these 4 numbers and I've had my students count by 2, 3, 5, and 10, and we'll go up to 10 times each, and we'll see what the numbers look like, see if there's any patterns and that sort of thing. And I've tried the flashcard thing with adults, and I just can't do it. It's to me, it's too childish. I did that with my children when they were young, but I just can't bear to do it with adults. It's just doesn't work for me. But I do want to show you this. So first thing we're going to do is we're going to count by 2. And I think we all know how to do that. I'm going to write them down. Write a sheet, these 4 columns on a piece of paper. Put these headings 2, 3, 5, and 10. And we're simply going to count by that number. So watch this. 2 over here. I'll start with 2. So we'll write down a 2. Now let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, we see the whole list there. Whoops, sorry. We see the entire list. 2, 4, 6, 8, 10. Guess what happens? It starts to repeat. 2, 4, 6, 8. And there's a 0 at the end, so then 20. These numbers here are called even numbers. And you may not know this, but I will tell you, on one side of your street, there will be even numbers. They'll end in a 2, 4, 6, 8, or 0. And the other side will be the odd numbers, and they'll end in the other digits that are remaining. But 2, 4, 6, 8, 10, those are all even numbers. In other words, all of those numbers, I can split them into 2 halves and get the same number on each side. So those are even. I'm going to call that right there, even. All right, now we're going to move over to the 5s. I'm skipping the 3s for last. I want to count by 5s, and then I want you to look at the pattern that's emerging, okay? And I remember somebody particular in my class just a month or 2 who learned this, and he was kind of excited about that. So I think you know who you are. I won't mention any names. Let's start. We're going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and stop. So 5, 10, 15, 20. You guys have all done that. So in many ways, you know your 5 times table and you're not admitting it or you're not acknowledging it. What's the pattern that you see here? Or do you see a pattern? Well, you should see a pattern. And every number alternates with a 5, a 0, 5, 0, 5, 0, and on and on and on. So 5 times any number is always going to end in either a 0 or a 5. There's never an exception. All right, let's go over to the tens. I want to count by tens, and that's another one that I believe you already know. So let's count to 10 by tens 10 times, okay? So let's see what happens. We start with a 10, 20, 30, 40, 50. Oh, this is starting to look familiar. 60, 70, 80, 90, 100. So 10 times 3, oh, that's 30. 10 times 7, oh, that's 70. Oops, put it there. 10 times 10 is 100. When you multiply any number times 10, all you do is stick a 0 on the end. If I multiply 6 times 10, guess what I get? 60. So that's a pretty cool number, and that's one that I'm going to need you to know. The reason why I'm getting you to do these 4 numbers is because they're the most important. If we can work with them, we can at least build a foundation for bigger and better things. So what can you tell me again about the 10 times table? Counting by tens, they always end in a 0. Never an exception. Okay, now the threes of these list of 4 different numbers, the threes are the most difficult, but even them, they're not difficult. But this has a real special quality I want to talk about. And let's start. So we'll go 3, 6, 9, 12. Not sure if I see any patterns yet. I'll keep on going. 15, 18. Still don't see any patterns yet. 21, 24, 27, 30. I don't know if anybody is going to see a pattern quite yet. Do we see any patterns in this column? 3, 6, 9, 2, 5, 8, 1, 4, 7, 0. There is a pattern, but I think it's a little bit above maybe what I'm trying to accomplish here. I want to take these two, the 5 times column and the tens, I want to take them off so I can have room to talk more about these threes. This is where there might be a little, you might have to watch this once or twice, or you might have to get me to come over and work with you, or you might even use this video as a reference for some division problems down the road. But here's something similar with all these numbers. And if you want to have a calculator by your side, in fact, I'll take that back. If you want to have your multiplication table, this one, by your side, and look under the 3 times table. First thing we get is the 3. 3 times 1 is 3. 3 times 2 is 6. We're going down the list, down the list, down the list, down the list. And watch these numbers here. I want to take this number over here. What happens when I have 1 plus 2? I get a 3. What happens when I get 1 plus 5? Where's the 5? I'm just splitting it up. It's the 1 and then the 5. So what do I get when I get 1 plus 5? I get 6. 1 plus 8. Oh, look at that. That's 9. That's pretty cool. So here we have 3, 6, 9. And then over here we split them up and added them. Guess what we got again? Another 3, 6, 9. I'm going to continue that and we're going to see what happens. So what about a 2 plus 1? Hey, that's pretty cool. See, people need to be shown things in order to see them. Sometimes you'll recognize something all by yourself, and that's called discovering something, obviously. But sometimes if somebody guides you, you can discover it with that person. So look what we're discovering here. All these numbers that are part of the 3 times table, they can be reduced to a 3, 6, or 9. Let's see if the whole list does that. 2 plus 4. What does 2 plus 4 make? That makes 6. 2 plus 7. That makes 9. Oh my goodness, the whole pattern keeps repeating. It's buried right under our noses. And finally, 3 plus 0 is equal to 3. Look at that. 3, 6, 9. 3, 6, 9. 3, 6, 9. 3. What do you think the next one would be? It would be 33, and that would those two numbers would add up to a 6. So, how many minutes am I at right now? I'm going to teach you a special trick. At least I'll introduce it, and I'll carry it through on the next lesson, okay? And here is the special trick. The reason why I brought this up was because we're moving into division. And the next lesson will be something called factor trees. And I want to show you something really fancy. Is, let's say, 78 evenly divisible? Okay, I just introduced a new term, divisible. Divide, divisibility, divisible, they're all taken from the same word. Is 78 evenly divisible by 3? Well, I don't think you're going to find maybe you will find a 78 on there. I don't know. Yep, you will. Well, you know what? I am going to show you how I know that 78 can be divided by 3. And this is an introduction to division as well. So watch this. Oh, I'll take this off. 7 plus 8 equals 15. Can I divide 15 by 3? Well, what happens if you add the 1 plus the 5? Well, that'll give 6. Yes, 15 is divisible by 3. You know it is. And so the answer to that question is yes. Now, I know I got a little bit off track here, and I apologize for that. But I will see you on the next video, and we are going to talk about factor trees, and we'll use what we just learned, okay? Take care. See ya.